All right, solving compound inequalities today, and what your learning target says is I can solve and graph compound inequalities that are in one variable. All right, so let's first go through some of the definitions parts of this. First, a compound inequality are two inequalities combined. Two inequalities combined into one more complex inequality. And there are two types of compound inequalities, okay? The first one is, we're going to call it an and inequality. This is called the intersection. Okay, and what intersection means is that's where two simple inequalities, or where their two graphs overlap. It's the intersection of both of those graphs, okay? So the shaded portion of these types of inequalities, the intersection inequalities or and inequalities, will connect the two values. They will go in between them. So what that looks like here is if we had a little graph and we had 2 points, an intersection and inequality will connect the two, okay? Now there's also an or inequality, okay? And that the combined inequalities are called a union. They join together in holy matrimony, okay? They're a union, okay? The graph of this set of compound inequalities contains what is true from both individual inequalities, okay? And the shaded portion of these graphs will be going in opposite directions, okay? So what this looks like, a union inequality or an or inequality, is if we had a point here, they join together to go in opposite directions, but they're saying both of these are going to be true. It's called a union inequality. So in order to solve these, graph compound inequalities, the very first thing that you're going to want to do is that if the compound inequalities, remember there's like two of them, are written as one inequality, then we need to split it into two different inequalities. Two in simple inequalities, okay? The second thing would be to solve each inequality for the variable like normal, okay? You would solve each one just like normal. And then lastly, you would graph the set of solutions that will make the inequality true. And then remember, one of the biggest things is to make sure you know if it is an and inequality, so only graph what they have in common, or if it's an or inequality, which means they have to graph both sets of the inequalities, okay? Let's do some examples. Example 1 asks us to solve the compound inequality 8 is less than 3x minus 1, which is less than or equal to 11, and then graph the solutions. Okay, so the very first thing that we have to do is break, this is one big long inequality, it has two little inequality signs. Let's break it into two different inequalities. So we're going to take this section and do 8 is less than 3x minus 1. And then also this section over that way, which is 3x minus 1 is less than or equal to 11. Okay. Now the second thing is we need to solve each inequality like normal. So we're going to first add 1 to both sides. We end up getting 9 is less than 3x. Divide by 3 for both of them. We end up seeing 3 is less than x. Okay, we solved this first part of the inequality. Okay, now the second part over here, we got to do the exact same thing. We're going to add 1 to both sides. We end up getting 3x is less than or equal to 12. Divide by 3. We see x is less than or equal to 4. Okay, so what we've just solved for this whole inequality here, we've found the values of what x can be equal to, and we need to first, before we go ahead and graph this, let's kind of look at this. This is saying that for values of x, it could be greater than 8 and it could be less than 11. Okay, what that means is that is an and statement. Okay, it is less than or greater than 8 and less than or equal to 11. So let's graph that. So we've drawn a graph. Make sure you draw a graph as well. We've got x is greater than 3. Okay, so we're going to put an open dot at 3. And we also know x is less than or equal to 4. So we need to do a closed dot at 4. Okay, and remember this is where they both are true. X is greater than 3. So that would be this way, and x is less than 4, which would be this way. But we only want the point in which they intersect. which is just that little spot in between them. Okay, and that's how you would graph an inequality that is an and inequality. Okay, the second example says solve the compound inequality 8 plus t is greater than or equal to 7, or, bing, 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 it's an or, not an and, so this is a little different. 8 plus t is less than 2, and then graph the solutions. Now, these have already kind of been split into two, so let's just go ahead and rewrite them, even though they are already split up. We've got 8 plus t is greater than or equal to 7, and 8 plus t is less than 2. Okay, so let's go ahead and we're going to solve for t for both of these. Okay, so let's subtract 8 just like we normally would on the last one too. We end up seeing that t is greater than or equal to -1, since 7 minus 8 is -1. And then we subtract 8 on both sides for this one. We see t is less than 2 minus -8, or 2 minus 8 is -6. Okay, so now we have our two different values. Okay, this is an or statement, which means that it is either one. It can it's a combination of both of these. Okay, it's the union of both of those. So let's go ahead and graph this. I've gone ahead and drawn it below here. So we've got t is greater than -1, greater than or equal to -1. So let's do a closed dot at -1. And t is less than -6, so that's an open dot at -6. Now, if we were to graph each of these individually, we'd see t is greater than -1. Well, values to the right of that would make that inequality true. And t is less than -6, values to the left of -6 would make those true. So we have now graphed an or inequality by placing the 2 points and then splitting those in opposite directions. Alright, finally let's do example 3 and example 4 here. We need to write the inequalities shown by the graph. And remember, and statements connect both of those parts. It is what is included in both graphs. Or statements or inequalities are ones that include both of them. They usually go opposite directions. Okay, so we know this one. This is going to be an or statement. This is going to be an or statement, and we can see that just because they go in opposite directions. It's including both inequalities. Okay, so we've got x. We're just going to use the variable x. You can use whatever variable you want. We know that x can be less than or equal to that -8, or x can be greater than, not equal to, but greater than 0. Okay, and that's how we would actually write a compound inequality given a graph. Okay, now example 4 is the same type of thing here, but we see that it is connecting the two dots, which means that this is going to be an and. Okay, it is the intersection of both of them, which means that our variable, let's call it x, is going to be in between both values. Okay, we know x is greater than -2, but it is less than 5. And you see how I did that is I just kept x in the middle. I made it greater than -2, but less than 5. And we've written our inequality, or compound inequality, that was shown by the graphs. All right, hope you enjoyed.